the question is the optimal way of transferring a space vehicle from an inner circular orbit to an outer coplanar circular, that means from here to here. Coplanar circular orbit is to fire its engines as it passes through A to increase its speed and place it in an elliptical transfer orbit. Another increase in speed as it passes through B will place it in the desired circular orbit. For a vehicle in a circular orbit about the Earth at an altitude h1 is equals to 320 km. This is 320 km, which is to be transferred to a circular orbit at an altitude h2. This is h2 height 100 km. Determine the required increase in speed A and B. Clear? So next, the total energy per unit mass required is equal. Okay. So now here it is. I am going to consider this as see, this is the distance it is going to be covered, right? This is the distance. So therefore now this is my RA and this is my RB. Okay, this is RA and RB. So now it is going to be applying of conservation of angular momentum. Conservation of angular momentum, CAM, conservation of angular momentum. So what it is, M into RA into VA is equals to M into RB into VB. So MM gets cancelled. So altogether VA is equals to velocity. VA is equals to RB by RA into VB. So if I substitute the RB RA values are there, so I will get VA is equals to 1.0718 into VB. This is the first relation. Okay. So next I have to find out the what is VA and what is VB, then VB minus VA. So for that, I have stuck over here. So I need to apply another concept. That concept is conservation of energy. So conservation of energy, COE. So let us discuss at point A. So at point A, so what it is? Total energy. So total energy. No, it is kinetic energy, not total energy. Kinetic energy. Kinetic energy A is equals to half into M into V square A. And what is the potential energy? Potential energy UA is equals to minus G M by RA. So if at all, see, I know the G value and I know the M value and small m value, and RA is already we have value. So if I am going to substitute the values, so what I am going to get? So UA is equals to 59.501 into 10 to the power of 6 meters. If you want, you can pause the video and you can find out this value. Why? Because see, we know only capital M and G and RA. So we doesn't know the small m. So that's the reason it is small m. So at point B, same thing. At point B, so at point B, so what it is? We are going to get UB. UB is equals to, how much we are going to get? 55.5 into 10 to the power of 6 m to 10 to the power of 6 m. Then both the sides, energies are equal. So therefore, kinetic energy at A plus potential energy at A, kinetic energy at B plus potential energy at B. So kinetic energy we doesn't have, half m. Directly I am substituting and I am replacing the words and rearranging the words. Kinetic energy into this side, that is minus half into m into V square A minus V square B. So must be equals to VB minus UB minus UA potential. So UB minus UA. So therefore, now this is the, let's say now this is the second relation, and already this is the first relation. So if I am going to substitute, I am going to get VA value, I am going to get velocity at A 7861 meter per second, and VB is equals to 7334 meter per second. Now I need to find out change. Okay, so is this the change? Okay, no. So in circular orbit I need the velocity. So in circular orbit I need the value. So what it is? Velocity A of circular. Okay, so under root gm by RA, under root gm by RA, so must be equals to, so if at all, if I am going to substitute the value 7714 meter per second. In a similar way, VB at C is equals to same thing, gm upon RB is equals to 7451 meter per second. So now delta VA is equals to VA minus VAC. So substitute the values, you will get the value 147 meter per second, and same delta VB is equals to 117 meter per second. Now I need energy per unit, second part means B bit. So B bit is what? So energy per unit, that means what? Energy per unit means kinetic energy upon mass. So half into V square. So half into V square means what? Half into delta VA square plus delta VB square. So if you substitute the values, so you are going to get 2.01 into 10 to the power of 6 joule per kg. This is your answer. Thank you.